Okay, let's solve problems, shall we? So don't forget that there are two types of quantities, scalar and vector. This video is about displacement, and the first and foremost, we need to categorize every single quantity that you learn in one of these buckets. Is it scalar or is it vector? Displacement is a vector. So vectors will always have that little, or they should have that little hat arrow on top. That's how you know. Scalars will never have that. So the definition is of displacement. Displacement is the change between the final and the initial positions. So anytime you hear word position, you know that you need x-axis. This displacement is change. Delta denotes change always. Change in position equals final position minus initial position, right? That's pretty straightforward. So I'm going to highlight that displacement is change, and then it is final minus initial. A lot of the times when you're actually solving problems, you may confuse that, but always tell yourself which one is final here. So here's a problem that we're going to solve. Give an example in which there are clear distinctions among distance traveled, displacement, and magnitude of displacement. Identify each quantity in your example specifically. So here we need to come up with an example of a motion, of some type of a journey, that different distance traveled, displacement, magnitude of displacement, all three are different from one another. Pretty simple, but still I'm going to highlight one thing, which is magnitude of displacement, and another way to calculate distance traveled. First way is like kind of intuitively, the second way is like formulaic. So here we just need to make sure that these three quantities do not equal each other. And once we have displacement, magnitude of displacement is one step away. We just need, displacement is a vector, it has direction as well as magnitude. We just need magnitude for the third part. Here is the answer to this problem. Here is the example that they asked for. I set it up. There are a million other options, but this is one of them. The middle home here, the black home, is your home, and as you can see, I already have x-axis going there, and I chose the positive direction to be towards right. You choose that based on what problem you're solving, based on what makes sense and makes it easy for you to solve it. Of course, origin, you're going to need origin, and I placed it where the journey begins because that also makes my life simple, so why not? And to the right is your friend's home, and to the left is the store. Okay, so you start at the origin, start from home, first go to your friend's home, and then you turn around, pass home, and go to the store. Your journey ends there. That's your final position. For the sake of displacement, the only thing you care about is initial and final positions. But for distance travel, the whole thing counts. So distance traveled is this green line. From home to your friend is 9. From your friend to home is another 9, 18, plus another 9 to store. That's where it ends. So that's 27. Pretty easy, intuitive. Then displacement is difference from final minus initial. So minus 9 minus 0, displacement equals to minus 9. That minus stands there to tell you something about direction. It is going opposite of the direction of positive direction of x, which you chose or I chose. So it's arbitrary. Could be, if I chose different direction of x, could be positive. So another way to calculate distance traveled is to take small individual displacements, take magnitudes of those displacements, and add them together, just like so. I'm going to split this motion into 2 because I turned around once. I'm going to split it there. So I'm going to kind of analyze 2 micro paths here. First one is from home to my friend, 0 to 9, and the second one is from my friend's home to the store. So from my home to my friend's place, within that path, final is my friend's, and that position is x equals to 9, and initial is home, that's 0, so at 9 minus 0 is 9. Then the second small portion of this motion is final is -9. So you take final -9 minus initial, which is 9 here, because in that, after you turn around, you started at your friend and then you went to the store. So -9 minus 9 is -18. Then you take magnitudes of those two displacements. Magnitude of first displacement, which was 9, is 9. And then magnitude of -18 is 18. So you add those together and it's 27. So there's another way to get distance traveled, formulaic way, so that you don't have to think through a problem. You can just calculate individual displacements, take only magnitude part of it, and then add them together, because distance traveled is a scalar quantity. It doesn't need or care about direction. So you kind of remove the direction aspect of displacement and you just keep the magnitude. That's how you get distance traveled. By the way, fun fact, your Apple Watch, if you have one, calculates distance traveled. If it was calculating displacement, then it would be 0. If you started home and you ended up home, if you know what I mean, it would be 0. That wouldn't make any sense. It would be sad, right? So always think about that. Distance traveled is how many steps I take during the day, and then displacement is where I started, where I end up, difference between the two. It's a vector, and then it has direction. Okay, I hope that cleared up those 3 quantities: distance traveled, displacement, magnitude of displacement.